So yeah, thank you very much for inviting me to talk. It's a pleasure, obviously, to be at the Life of Space conference. So obviously, as my talk title would suggest, I am going to be talking today about why space analogs are important and also how you can get involved in them. So what are space analog missions? Well, in this instance, analog it just means analogous to a real space mission. So analog habitats simulate a space station or a Martian or lunar habitat. They can vary in fidelity, but the goal is to simulate the protocols and environment as closely as possible. So for example, they usually incorporate airlocks, EVA suits, extravehicular activity, that stands for, and resource management. So managing things like energy consumption, water consumption, food consumption, and all of those things, which actually make analogs a great place to test out and experiment with sustainability research as well. A lot of the closed loop and regenerative systems that you would require in space can have a very beneficial effect to life on Earth as well. So NASA has been using analogs since the Apollo days. NASA, ESA, and others also continue to use analogs to conduct research and for mission readiness. They're also used for scientific research, testing equipment, crew dynamics, human factors research, protocol testing, and many other things. So we need to be able to practice in a relatively safe environment before venturing into the hostile and extreme environment of space, the Moon and Mars. And this is really where analogs come in. And the ultimate goal is to strive to improve human spaceflight via simulations on Earth. And analogs provide a unique environment for individuals and researchers and academics and institutions and private companies to conduct their research. And it's a great opportunity for you to conduct your research as well. So this is just a quick map of some of the locations of just some of the world's analogs. It's not a comprehensive map showing all the analogs, but this is just showing some of the more active habitats and missions that are currently being carried out. And this is, again, not an exhaustive list of analogs. It's just to illustrate that there have been and continue to be many active participants in the world of analogs. So this is an example of one of the habitats. These were taken during my mission at MDRS, which is the Mars Desert Research Station in Utah. All the habitats are very different from each other. MDRS has a unique geology that is quite arid and analogous to Mars geology. During my mission, here we have a biologist who's conducting several research projects on plant life, taking samples from the field during EVA's extravehicular activities. So the layout of this particular habitat is pretty modular. So you can see here, this is the main living quarters and the main module. This is a two-story module. Upstairs, we had our living quarters, which are photographed here on the right. And this also had the sleeping quarters as well. Downstairs was like a sort of a storage area, and also the area where we got ready for EVA missions, where we had our EVA suits and other equipment as well. And it could be used as an exercise area or an area to bring some of the lab work into the main habitat if needed. These tunnels here, these connected the modular systems. So here we had, this was one of the science labs over here. Behind that, this small, I think you can see my arrow, small module here. This was the observation deck as well, observation dome. Over here, this was the green hab. So this is where we could grow plants. And to the left, just behind this mound, this was where we had the engineering lab. And this is where it was, all the engineering tools were based, and we could do work on some of the rovers if we needed to as well, and other robotics and engineering projects as well. And you can see, so aside from obviously conducting research, there's also very important to have downtime. So here, two of the crew are enjoying a game of space chess during I believe a Sunday afternoon, some downtime there as well. During our mission, we had several research projects that ranged from psychology, biology, and engineering. But we also practiced emergency drills and protocols by simulating various disaster scenarios. And there were a lot of great learning outcomes from those. So these analog simulations can be great for testing those kind of things as well. These are just some photos of our EVAs. So you can see the type of geology that the MDRS habitat has and why it's analogous to Mars. So these are some of the EVAs where we were searching for biological samples for Katie's research project. So this is a list of just, again, very limited, not exhaustive list of some of the active habitats that you can apply to be part of a mission. So these include MDRS that you've just seen, which has the unique sort of Mars analog geology. High Seas, which is also, so MDRS is based in Utah in the US. High Seas is based in Hawaii on the Big Island, also the US. It has very unique volcanic geology, lava tubes and skylights. Lunares and AATC are both based in Poland. Lunares is a full isolation mission with an internal EVA area. So when you participate in a Lunares mission, you never actually set foot outside during the entire mission, which is actually, you know, that in itself is a very unique challenge to participating in the Lunares mission. And the team at Lunares, they are made up of space architects. So they are very active and proactive in creating a efficient, practical working environment that's also comfortable. So the architecture of Lunares is very nice. AATC is an educational training program they conduct, and they're owned and operated by a private team. SAM is one of the newer habitats that's built on the University of Arizona campus, where also Biosphere 2 is in Arizona, USA. It's probably the most high fidelity of these habitats. It's fully pressurized and hermetically sealed. DMARS at the moment is the only really active Middle Eastern habitat, although there are many more newer habitats that are cropping up all the time. And I believe some of these are based in the Middle East as well. And the same Habitat Marti is the only operational Southern Hemisphere habitat. And they were actually also conducting virtual missions. So it's a great way of just kind of learning more about what's involved in an analog mission if you wanted to participate virtually and weren't able to actually get to the habitat itself. It's more of an educational experience. Again, they're currently the only one operating the Southern Hemisphere, but there are many new habitats cropping up all over the place all the time, including talks of bringing one to Australia, I believe. So many of these habitats run regular missions that you can apply to join and bring your own research project to. If you have an astrobiology or life sciences research project or any subject matter for that, you think could benefit from the environment of a space simulation or the unique geologies that some of these habitats are located in, then apply to a mission and bring your research along. Okay, so what are some of the other analog activities that you can get involved with aside from joining a mission? So I'm going to talk more about all of these that I've listed here on this slide. So as Adriana mentioned, I founded the Analog Astronaut Community and Conference, and these are both things that I would encourage everybody to be involved with. The International Guidelines and Standards for Analogs, I'll talk a bit about that. The Analog Astronaut Research Database, and the world's biggest analog. So anyone can join the Analog Astronaut Community. It's totally free. The link is up here in the left-hand corner if you wanted to join. And really, the mission of the community, or creating the community, the purpose was to create a centralized and thriving community for analog astronauts, a platform where we can collaborate, share research and ideas, and talk directly to each other and habitat directors. As a community, we advocate and drive forward projects, missions, and solve problems in the interest of our members. Each year, we also have the Analog Astronaut Conference, where you can present your research. Next year, we'll be having it 9th to 12th of May in 2024 at Biosphere 2 in Arizona. Biosphere 2 is the perfect setting for our conference. Theme for next year is analog research for the benefit of life on Earth and beyond. And I invite everybody to go to the link here at the bottom, analog-astronaut.com. You can purchase discounted early bird tickets. They're on sale now. And you can also submit an abstract to present at next year's conference. Okay, so what is the centralized research database? So the centralized research database for analogs is designed to avoid duplication of work and build on the body of existing research. We will use it to capture the work being done on analog missions, even if it's not published yet. It's going to make it easier to identify research gaps, and it will be a repository of data that researchers can use outside of missions as well. The international guidelines and standards for analogs. So this, earlier you heard me mention that there's a lot of variability between the different analog habitats. Well, the goal of the standards is to somewhat quantify those differences and also improve the quality of each habitat. So additionally, I say the purpose is to prepare recommendations that optimize the fidelity, the safety, and the integrity of the individual habitats and missions, and to guide training programs and activities. So the objective is to set a gold standards, and this will provide opportunities for current analogs to improve on their existing standards, and also a framework for newer analogs that are up and coming. So there's a number of benefits I've listed here. I won't go into too much detail here, but if you do want to learn a bit more about the standards, if you want to read the standards, they are available on this website here, and you're welcome to go check that out. Okay, so this is probably our most ambitious project so far. This is the world's biggest analog, and it is planned for 2025. So the world's biggest analog is uniting the world's analogs. We're supporting and raising awareness for new and existing analogs globally. And we are creating a global education program that aims to target underserved communities. We're also collecting data from the largest and most diverse set of analog astronauts in history, making this data available as a resource for researchers worldwide in that database that I just mentioned. So the world's biggest analog, what is it? It's an international collaboration to unite the world's analogs through a unique and historical mission, coalition of experts tackling the challenges of living and working in space. In the near future, there will be settlements in space. NASA is already planning a permanent base on the moon. But these settlements are not just going to be NASA, it's going to be other government agencies, but also private industry from various different countries in the world. So there's going to be a lot of different countries, cultures, and industries involved in building these permanent settlements on the moon or Mars. And they're all going to have to work together and collaborate in the hostile environment space. I always like to use the analogy of Antarctica, where you have different countries, different nations with their bases, but they do come together and they help each other because of the hostile environment. And something similar will have to happen when we have these space settlements. So the world's biggest analog, its intention is to simulate this off-Earth settlement. And the way we're going to do this is by running a 1-month-long mission that is going to allow all the world's habitats to simultaneously take part in a collaborative research mission. And as I said, that's planned for 2025. So it's to answer the question, how will we live and work in space? The primary goal of WBA, for short, World's Biggest Analog, is to conduct rigorous science, collaborative research, and develop protocols. The secondary goal is to raise awareness via media and education platforms and other outreach. This will be the largest space analog mission carried out in history and the only one simulating multiple outposts, making WBA the first of its kind. So as I mentioned, it's a 1-month-long mission in September 2025. There will be over 40 staff managing the Mission Support Center. There will be over 60 crew members, probably of the order of 100 crew members, with at least 10 participating habitats, probably more. We will be creating a documentary film. There's also going to be an educational game as part of this, as part of the global education program. The research will be collaborative. There'll be communications protocols, and there'll be cross-cultural research done as well. We will be implementing the standards and guidelines that I talked about earlier. And we will be populating the Analog Astronaut Research Database. So what are the impact and goals of the world's biggest analog? As I did mention, this will be probably the most diverse crew of any analog mission, also the largest crew sample size. We are very much advocates of diversity, equity, and inclusion. We aim to carry out some sustainability research to demonstrate that space research has a direct impact on Earth. The goal is to conduct replicable scientific research. This is quite a key component of this, and collaborative research. We will be doing a lot of science communication through the outreach program and education program. There will be an impact on local communities as well, hopefully a very positive impact with our outreach and social activities. We'll be looking at community building as part of the research program. And as I mentioned, we will be collecting data that will be entered into the database, and we will be making that available to the public, obviously keeping within the framework of data protection and ethics review boards and all of that good stuff. And as a result of this collaborative research, given that this has never been carried out before, then we're expecting some new studies to emerge from this. And again, like I said, we'll be rolling out the standards and best practices during the world's biggest analog. At the moment, we do have an open call for research. It is pretty close to the deadline, 15th of December. You can go to worldsbiggestanalog.com/researcher if you wish to apply or learn more about that. Although the deadline's pretty close, I do invite and encourage people to apply. You don't have to have all the details figured out yet. This is the first stage of this application process. It is really just a notice of kind of interest or intent to carry out research on WBA. So again, these are just some of the basic details of what WBA is. All research ideas are welcome. You don't have to be affiliated with a university or a private company. If in any doubt, if you're wondering whether you can or should apply, I would say definitely apply. And we'll be in touch with you if you have any questions about your research. So no reason not to make an application to that. Okay, so just quickly, because I think I've run out of time. These are just some of the links again of how you can get involved in all the activities that we're working on. But because I've run out of time, I will exit out of that. And
Jas, thank you so much for your insightful talk and sharing all the opportunities that the students and scientists can get involved in the world's biggest analog studies and also other types of analog missions. Unfortunately, I don't think we have time for questions. So with the interest of time, we're going to move to the next speaker. But thank you so much for sharing your insights. And I'm going to forward your questions that were dedicated to you. And maybe we can get your answers at the later time.
Okay, thank you.
Thank you.